Dear students, as a part of the subject measurement and instrumentation, in the last part lecture we have learned about what are the various different units, topics, subtopics as a part of contents that we are going to learn under the subject measurement and instrumentation. So in today's lecture we will start with the actual course content. So as seen, the chapter number 1 what we are going to learn in this subject is named as basic concepts of measurement. Now in this particular chapter what we are going to learn is briefly summarized over here. First of all, we will see what is the definition of measurement, means how we can define the term measurement. Then we will see what is the significance of measurement. Next, we will see what are the advantages of measurement. Then we are going to learn about the methods of measurement, in which there are two methods: direct method of measurement and indirect method of measurement. Next to that, we will learn with the help of a block diagram what is the elements, what are the different elements of the generalized measurement system, their associated things and functions of each and every block. Next to that, we are going to learn about the performance characteristics, in which there are two characteristics. One of them is said to be as static characteristics of the instrument, and the another is said to be as a dynamic characteristics of the instrument. Okay, and after all this, last part what we are going to learn is about the errors in the measurement, the sources of all those errors, and the different types of errors along with the calculation. So let us start with the first ever thing what we are going to see is definition of measurement. So what has been said, measurement is the act or a result of a quantitative comparison between a predetermined standard and an unknown magnitude. Means what? When we are going to measure a particular thing, a major quantity or any parameter as such, what we actually do is simply we compare the unknown parameter with the known scaled unit. Okay, means what? Suppose, let us take an example. Suppose you have a scale with you on which the marking is been done in millimeters, centimeters or inches as such, and you want to measure a length of a particular substance as such, or a length of a stick suppose. So simply what you do, you take the stick near the scale on which the units are being printed, you just compare a stick with the scale and you come to the conclusion to what is the length of that scale, either in millimeters or centimeters or inches. Okay, so simply what we do is we just compare the two things. What we compare? We compare the unknown thing with the known standard value, and that is how we are going to define measurement. So simply, what is measurement? Measurement is an act or a result of a quantitative comparison between a predetermined standard and an unknown magnitude. Okay, so let us see now what is the significance of measurement. Okay, so as you see here, the significance of measurement can be briefly summarized in such a way. Let us read it first. What has been said? The first significance, what has been said here is measurement plays a very significant role in every branch of scientific research and engineering processes, which include control system, process instrumentation, data reduction, etc. So what is there? This measurement is required in every branch of research. So suppose whenever any research is to be carried out, whatever parameter that particular system involves, we should know the values of each and every parameter. Okay, or whatever engineering process you are going to do, or a particular system you are going to control, or a particular instrumentation you are going to apply for, or any changes in the data you are going to do. In that, the most important thing is you must know the actual values of that parameters. And so as to know that actual value of parameters, what is important is you have to measure it. Okay, so that is the first thing. Next, what we can say, the whole area of automation and automatic control system is based on measurement. The precise control is possible only with precise and accurate measurement. Means what? Suppose you want to do a particular system to be operated automatically, or if you want to design a particular system which can be controlled automatically, in that system very precise control can be done if you are well aware of the values of the parameters within that particular process, and hence to know the values of the parameters the measurement is required. Okay, so that is the second significance. Next, the third point what has been said here is the design of a product can be improved with confirmation by measurement. Suppose you are designing a particular product. Now whatever may be the parameters that are existing for that particular product, you can improve its design when you are well aware of the values of the various parameters, and so as to know that values you need to have a measurement of that values. Okay, so measurement is important during the design of the product. Next, fourth point what has been said, the process can be operated with maximum efficiency, minimum cost through measurements at each stage. Means what? Suppose if you are having a particular process, then if that process requires various different stages, then if you go on measuring the changes in the parameters during the process at each and every stage, we can make that particular process to operate at a highest efficiency and by bearing very low cost if you are going to measure the parameters at various different stages. So again, during that process, that measurement plays a significant role. And finally, what is been said as a fifth point here is a measurement leads to new discoveries that require new and sophisticated measuring techniques. Means what? When you are going to go on measuring a particular parameter as such with the help of any particular device or a particular measuring instrument, then you can come out with the new techniques that can be implemented for the improvement of all those particular process or all those particular parameters. Okay, so that's what we can say is the significance of the measurements. So that is all about the significance of measurement. Next to this, now we are going to see what are the methods of measurement. So as you see here, the two methods of measurement are said as direct and indirect. Okay, so whatever measurements that you are going to do, we can do a measurement of any particular parameter or a particular value by either of the two methods. What we call is a direct method of measurement and another is a indirect method of measurement. So let us see what is direct measurement. Okay, so what has been said here, in this direct method, the unknown quantity is directly compared with the known standard. The result is expressed as a numerical number or a unit. Direct methods are used for measurement of physical quantities like length, mass, time, etc. A human being can make direct length comparison with preciseness of a few millimeter. So it is not possible to make very accurate measurements by direct method. Direct method of measurement is not always possible, feasible and practicable. These methods are inaccurate because they involve human factors. These are less sensitive and hence are not preferred and are rarely used. So what is being said here is, what is actually direct measurement? A direct measurement is one where we are going to compare the unknown parameter or an unknown quantity with the known value. So as it has been said in the earlier example, Suppose if you want to measure the length of any particular substance, like let us suppose we want to measure a length of a stick. So what we simply do is we are having a particular scale with us on which the length is marked with the markings like millimeter, centimeter or inch, etc. And what we do is simply we take that scale near the stick and we compare it. Okay, so here what is happening, we are directly comparing the stick length with the known scale. Okay, so here this method is said to be as an example of a direct measurement. Now here what happens, we are directly involving a human being for this comparison. There is no any as such a automatic or a device that is doing all these things. The comparison action is done by a human being. So it may happen that while looking towards the scale, it may happen that the values of millimeter, whatever we are going to take as a final value of the length of that particular stick, it may happen that it will be having a error of certain millimeters. Okay, so what we can say is the preciseness totally depends on a human being who is comparing these things. Now this is an example of length. Similarly, it can be applicable for a mass, that is weight measurement, or it can be applicable for time as such. Okay, so wherever a human being is involved and wherever the direct comparison between known value and the unknown parameter is being done, that is said to be as a direct measurement. Now what happens is this is only possible for a few parameters only. Okay, but when the quantities or parameters are of different kinds, always it is not possible to apply this direct measurement. And for those all different quantities, we have to adopt the another method, what we call as indirect method. Okay, so let us see what is indirect method in brief. So as you see here, indirect method, what has been said? The indirect method makes a use of some form of transducing device coupled to a chain of connecting apparatus known as measuring system. The chain of devices converts the basic form of input into analogous form, which is then processed to produce an output as a function of input. The processing of this signal may be in any form, which includes amplification or filtering, etc., which is sensed by any measuring instrument at remote place. So what do you understand by indirect method? Now here, as you see, in case of direct method, we were comparing the unknown value with the known value directly. But here we are not going to do in that manner. In case of indirect measurement, we are not going to involve a human being directly. But there will be a certain devices or a chain of the devices or apparatus which we are going to connect to each other to form a total measuring system. Okay. Now, what has been said, we are going to make a use of transducing device. Now what is meant by transducing device? Here what happens is whatever parameter that you are going to measure, that parameter is of various different units. Okay, suppose if you want to measure a temperature, temperature's unit is degree Celsius. If you want to measure certain another thing like a speed is measured in a rotating speed. If you consider, we measure the rotating speed in revolutions per minute. Okay, so different parameters are of different units. Now instead of measuring these parameters directly in its unit, what we are going to do is we are going to use a transducing device. What is a transducing device? This transducing device which will convert the actual quantity into its analogous form like current or a voltage. Okay, so what has been said here, the chain of devices converts the basic form of input into analogous form. Means what? Suppose you are measuring a temperature, then in a case of an indirect measurement, that temperature in degrees Celsius we are going to convert into EMF, which is analogous electrical signal. Okay, or else suppose if you want to measure the speed, that speed in revolutions per minute we will convert it into its analogous form, that is in terms of EMF again. Okay, means what? A transducing device will convert the basic form of input into analogous form. Means a temperature in degrees Celsius will get converted into electrical voltage, or speed in revolution per minute will be converted into electrical voltage as such. Okay, now this converted form, whatever is there, that is then processed to produce an output as a function of an input. Means what we are going to do is, we have converted degree Celsius into electrical voltage, then we will process that electrical voltage in further apparatus such that the final output will be again in degree Celsius. Similarly, suppose you are measuring the speed in revolution per minute, that speed in revolution per minute, which is a basic form of input, will get converted to analogous form, means it will be converted into electrical voltage, then that electrical voltage will be processed further to produce an output in again the same form, revolution per minute. Okay, so that all apparatus connected to each other in the form of chain constitutes a particular measuring system. So indirect measurement is one when we are going to make a use of all these connecting apparatus connected to each other as a form of a measuring system. Okay, now what happens is, the processing of these signal may be in any form, which includes amplification or filtering, etc., which is sensed by an measuring instrument at a remote place. Means what? Whenever we are changing the electrical voltage into its known form as a same output form, then that voltage may be processed further to amplify it with the help of amplifier, or we can pass it through the filters to filter the unwanted signals from it, etc. And whatever final output we are going to get, that final output will be given to the instrument, which can be placed at a remote place. Means it may be anywhere away from that particular parameter where it is measured. Okay, so that is all about indirect measurement. So in case of indirect measurement, simply there is no any involvement of human being, there is no any direct comparison. What happens is, we are going to use a different transducing devices or a chain of connecting apparatus, which is known as measuring system, and first whatever parameter you are going to measure, that you are going to convert into electrical signal. Then that electrical signal will be given to various different apparatus, like you can amplify, filter, etc., etc. And then that electrical voltage, electrical signal then will be again converted into the basic form of that parameter. Okay, so all this, what happens is what we say as an indirect method of measurement. Okay, so as you can see, whatever further things we are going to learn as the part of this chapter, in that you will find each and every parameter what we are going to measure is majorly done by a indirect measurement method itself. Okay, well, after this, next point what we are going to learn is elements of generalized measurement system. Okay, means suppose if you are doing an indirect method of measurement, that particular measurement system will have different things or apparatus connected to each other. Okay, now as you see in this block diagram, we can say what are the different things that are, or blocks that are present in a measuring system. Okay, so as you see here, the first block, what it shows input signal or measurand. Means what it is, It is the parameter what you are going to measure, or it is a quantity what you are going to measure. Next, what we have done, we have given that input parameter, input signal, that unknown parameter to the transducer. Okay. Next, after the transducer, that is passing through the signal processing or manipulation element. Okay. Next, it will be given to data transmission element, then it will be passed to the data presentation element, and then it will be presented either in the form of indicator or to the recorder, or it will be passed to the controller. Okay, now let us see what is the function of each and every block. So first of all, input signal or measurement. So what you see here, measurement or input signal, what it is, any electrical or non-electrical quantity which is under measurement, observation or control is called as measurement. Example, it may be a temperature or pressure, speed, etc. etc. So what unknown quantity that you are going to measure, that unknown quantity may be electrical or non-electrical quantity. Electrical quantity means it may be power, energy, voltage, current, etc. It may be electrical or non-electrical quantities like acid, temperature, pressure, speed, etc. So any of these parameters which is unknown to us, which we are going to measure, is nothing but a measurement or input signal. Okay. Now that measurement or input signal is fed to the next block, that is transducer. So what is transducer? In short, it has been said that this transducer element converts the signal from any physical form to another without changing the information content of the signal. Okay, so in short, I would like to tell you is that what this transducer does, whatever is the parameter that is you are going to measure, that parameters unit is directly going to get converted into an electrical signal. Okay, one form of energy into another form. Means, suppose if you are measuring the temperature, the degree Celsius will get converted into voltage. If you are going to measure the speed, revolutions per minute will be converted into electrical voltage as such. Okay, so the output of this transducer is just in the form of an electrical signal. It is in the form of a EMF or a voltage. Now once we have converted that basic unit into electrical parameter like a EMF or a voltage, that we are going to feed to the signal processing or manipulation element. What is signal processing and manipulation element? What it does? See, this element operates on the signal according to some mathematical rule without changing the physical nature of the signal. This may consist of filtering, modulation, integration, differentiation, inversion, addition, subtraction, analog to digital conversion, etc. Means what? Whatever electrical signal that is coming out of the transducer, that we will give to the signal processing and manipulation element, and we will process on that electrical signal. That processing can be of any one thing. We are going to filter a certain thing, a certain signal, means unwanted frequency we are going to remove. Modulation means we are going to increase the magnitude, or amplification you are going to do. Integration or differentiation or inversion, that is changing the cycles, negative to positive, positive to negative, or addition or subtraction, or analog to digital conversion. Anything is, whatever is necessary or to be done on that particular signal will be done in a signal processing or manipulation unit. Now once the signal processing or management element works on that particular signal, that signal is given to data transmission element. Now data transmission means what? Suppose whatever measuring you are going to do, and if you want that values at a remote place, we are going to use a data transmission element. So what this element is? This element transmits the signal from one location to another without changing its information contents. It may consist of electrical cables, radio links, etc. Means simply whatever signal that is available out from the output of this signal processing or manipulation unit, that will be transmitted to the remote place or the remote element or a remote device by using either the cables or the radio links, etc. So that is data transmission element. And after that, the next block what comes is the data presentation element. Means what? The element provides a display record or indication of the output given by manipulating element. Means what? Whatever output we have received after conversion in the signal processing unit, when it is transmitted through the data cables, we have to present that values of that parameters. Either we can present that data in the form of an indicator, or you can give that data continuously, which is varying respect time, to the recorder, or you can feed that data to the controller. That controller can control the further process, okay, as and when it is required. Okay, so that is how is said to be as a elements of generalized measurement system works with coordination with each other. Okay, so let us summarize. What we can do is this shows the block diagram of a generalized measurement system. First, whatever input signal or measurement is there, means whatever unknown value is there, that is given to the transducer. Transducer's function is to convert the basic unit of the unknown parameter to convert it into electrical signal. That electrical signal in terms of EMF voltage is given to signal processing unit. This signal processing unit will work on that particular signal. Either it will increase the magnitude, it will manipulate with it, like filtering can be done, modification in the signal can be done, and after all that, that will be given to data transmission element. It may be anything like cable or radio signal, etc., radio link, etc., and then that transmitted data will be presented with the data presentation element, either in the form of an indicator or a recorder or a controller. Okay, so that's what is about elements of generalized measurement system. Okay, so hope you all have understood this. So with this, we are concluding our lecture for today. Okay, thank you very much.